Welcome back from the break. So we want to talk about briefly, okay, and then won't go into so much detail, but what you need to understand when we say HB electrophoresis, in case you are shown this, an investigation, and you are shown that it is told you that look at this HB electrophoresis and then predict the HB of or the genotype of these patients. What did you see? Now you see, this, I decided to do this lab, okay? Initially, it was not part of my plans to do the lab. I decided to do the lab because of what came in November. I mentioned earlier that they said they said a 6-week-old infant is enrolled into a newborn screening program. He does isoelectric focusing. Sorry. He does isoelectric focusing and was found to have an FS HB pattern. What is the immediate intervention? A, start folic acid. B, start anti-malarial. And I think C was to, I think, start, what was that? Start oxygen therapy or so. And then D, start penicillin. Okay. Can you screenshot this question? We'll come back to it. Okay.
Okay.
Okay, Doc.
So can I take it off?
Yes, Doc.
Okay. So in plain terms, I don't believe in telling you technical definitions when there is no need to tell you technical definitions. Like we tell HB electrophoresis a lab investigation used. No. When you hear of HB electrophoresis, you are trying to what? Determine the type, okay, the type of HB in a patient's red blood cell, the type and quantity into HB, the type and quantity of what? Or let me still, I just think I should write the type or types, okay? I think the quantity is not determined by the HB electrophoresis, but the type or the types of HB, the type or the types of hemoglobin in a patient's red blood cells. Do you get it? Because we know that red blood cells, okay, red blood cells contain HB. The question is, what are the various HBs that we can have? We can have a lot. I'm sorry, we can have a lot of them. Okay, can have a lot of them. So you, Michael, for instance, what is your genotype? What is your hemoglobin genotype? Are you AA? Are you AS? Are you whatever? We don't know. Do you understand? Do you understand?
Yes, sir.
Yes,
Good.
Doc.
And so what we do is that before we move on, I need to make some distinction. Okay, I need to give you some definitions or some explanations because I'll be testing your strength on these things. Now listen, when we say sickle cell disease, listen to me carefully. When we say sickle cell disease, you have this concept. You can have sickle cell disease, you can have sickle cell anemia, you can have sickle cell trait, okay? Sickle cell trait. Sickle cell trait. And you see, for your level, what I'm going to say is that there are so many types of hemoglobins. Have you noted these three down?
Yes, Doc.
Yes. So I'm going to say that there are so many hemoglobin types. We have hemoglobin A, that is the adult hemoglobin, isn't it? And that is a normal hemoglobin every adult should have. So this is the normal adult hemoglobin. The normal adult hemoglobin. Hemoglobin A. Normal adult hemoglobin. Then we have what? Hemoglobin C. This is abnormal. Okay. So apart from hemoglobin A, any other hemoglobin is abnormal. Hemoglobin S, isn't it?
Yes, Doc.
Then for the fetus, we have what? Hemoglobin F. You can have hemoglobin D. You can have hemoglobin beta tau. Okay, hemoglobin beta naught or beta 0. Do you understand my point?
Yes, Doc.
And for an adult, this is what you should have. All these are Sanquases. Do you get it? And so when we say sickle cell disease, what do we mean? So sickle cell disease is a hemoglobinopathy. Number one, it is a hemoglobinopathy. So last, I was trying to explain that pathy means what? Disease, like the angiopathy, amyloid angiopathy. Do you remember? So hemoglobinopathy is a disease of the hemoglobin. So what occurs in this hemoglobinopathy? We are saying that sickle cell disease is a hemoglobinopathy. What does it entail? You know that for every cell you have, you get two genes, right? One from mommy and then one from daddy, isn't it?
Yes, Doc.
Two sets of genes. So it means that you can only have what? HBAA or AS, meaning one came from daddy, one came from mommy. So sickle cell disease, when we say sickle cell disease, we mean a hemoglobinopathy, in which there are what? There are two abnormal hemoglobins, isn't it? So all the two hemoglobins are abnormal. And in addition, and at least one of the hemoglobins, at least one of them should be S. Do you get the point? So we are saying that we have a hemoglobinopathy. All two of them are abnormal. So when we say abnormal, we mean what? SC, beta tau, SC, beta tau, beta naught, D, L. All these are abnormal hemoglobins. But if you have CC, although the individual has abnormal hemoglobins, two of them, you can't call it sickle cell because per the definition, you said that at least one of the hemoglobins should be an S. Once you have an S plus any other abnormal hemoglobin, then you have a sickle cell disease. Do you get it?
Yes, Doc.
At least one of them. So it means that HBSS is a sickle cell disease because at least one of them was an S, but unfortunately the other is an S. Okay? HBSC. Yes, it is a sickle cell disease. Why? Because two of the hemoglobins are abnormal, and at least one of them is an S. HB SD is also sickle cell disease. HBS beta tau. It's a sickle cell disease. Beta tau, sorry. HBS, let's say L, is also a sickle cell disease. But H, do you get it?
Yes, Doc.
But HBCC is not a sickle cell disease, but it is also a hemoglobinopathy. But it is not a sickle cell disease because none of the hemoglobins even is an S. Now, among the sickle cell diseases, HBSS is the sickle cell anemia. So if you have a sickle cell disease in which both the abnormal genes are S and S, then you are said to have sickle cell anemia. Have I communicated?
Yes.
So now we've discussed sickle cell disease, sickle cell anemia. Then we go to sickle cell traits. Sickle cell traits. Sickle cell traits. So that one, you have what? HB, one of the hemoglobins is actually a normal one. So HBAS, HBAC, all these are what? Sickle cell traits. Because one of them is a normal HB. Do you understand?
Yes, Doc.
So it means that as individuals, once you have HbAA, you are said to have a normal hemoglobin, and so you don't have a hemoglobin, a hemoglobinopathy. Another individual can be HbAS, that's a trait. HbAC, that is a trait. HbSC, that's a sickle cell disease. HbSS, that's a sickle cell disease, also called sickle cell anemia. HB beta tau, and all that. Do you see that? And
Yes,
so,
Doc.
how do you determine the genotype? We use the HB electrophoresis. Now, the HB electrophoresis actually uses a paper, different papers, okay, or different different media or mediums. The most common is actually the cellulose acetate paper. The cellulose, so there is a paper called the cellulose acetate. That's the most commonly used. The cellulose acetate paper. Now, what do they do? We take blood, isn't it? And we put it in a bottle. Which bottle do you think we'll put this sample in? Now, Suma. Obosua.
The yellow bottle.
No, it's the EDT bottle. Remember,
The
hematology,
purple.
hematology. Because if you put in a yellow bottle, the yellow bottle doesn't have an EDC. So if the blood clots inside, how would you be able to lyse the red blood cells? Do you get it?
Yes, Doc.
Then what they do is that they take some of the sample and then what? They break the red blood cells down to release the hemoglobins in the red blood cell, isn't it?
Yes, Doc.
Good. Now what happens is that then they what? They pick the sample of the lysed red blood cells and then they put it on the cellulose acetate. The cellulose acetate paper. Hey, cool. So they put maybe patient A. Let's say that they have about 6 patients they are testing, okay? So patient A, patient B, patient C, patient D, let's say 5 patients. So they put their sample. So you put your sample here, put some sample here. Sorry. They put some sample here, and then they put some sample here. Now, the truth is that each of the hemoglobins, A, C, S, F, and all that, each of them has what? A different speed at which they run. Okay? They can run a certain distance and then they won't run again. For example, and their speeds are actually put up here. What I used to remember is what? CSF. C, S, F, A. Okay, CSF, cerebrospinal fluid. What this tells us is that C is the slowest, okay? It can only run up to this point. Do you get it?
Yes, Doc.
When you draw the paper, just put CSF, then of course the A comes here. So C can run up to this point. It means that the next fastest after C is actually S. The next fastest is what? F. And the fastest hemoglobin you can ever get is A. MCQ paper, MCQ, you kind of saying, writers. The fastest hemoglobin on the cellulose acetate paper is what?
A.
Yo. Yo. So they leave it there. Okay. And with time, the HB of the patient would separate. Okay. So let me give you an example. But are you getting me?
Yes, Doc.
So this is how the HB electrophoresis results may be presented to you. Then you are asked, what do you think? So Ofosua, let's begin with you. Ofosua,
Yes,
which
Doc.
of the patients, identify the patients who have sickle cell disease? That's the first question. Let me write the question now. Wait. Identify the patients. Identify the patients with sickle cell disease. Yes, answers.
Patient C.
Patient C. Okay, who else? Is that all? The patient with sickle cell disease. Oh. Yes.
Patient D.
Patient D doesn't have sickle cell disease.
Patient
Okay,
A.
so wait. Okay, it seems I went too far. Let's start. What is the genotype of the patient whose blood was put at point A?
S.
HBSC, isn't it? Because you find the band in S, sorry, in C and in S. Do you get it?
Yes, Doc.
Silent majority.
Yes, Doc.
What is the genotype of patient B?
A.
HBAA, isn't it?
Yes, Doc.
What is the genotype of patient C?
HBSS.
HBSS. What is the genotype of patient D?
HBAS.
HBAS. What is the genotype of patient E?
A. HBAC.
HBAC. So now I come to you. Ofosua, identify the patients with sickle cell disease.
Okay, patient C, patient D, patient
Patient
No,
D
it's
doesn't have.
A and patient C. Patient A and C.
Patient A and C, yes. Patient A and C are those with what? Sickle cell disease. Now, who can patient C marry? Who among the patients can patient C marry?
Patient B.
Okay, all of you agree, right?
Yes.
Yes, doc.
Okay. Which of the patients, so which of the patients has sickle cell anemia?
C.
Patient C.
Which of the patients have sickle cell traits?
Patient D.
D and E.
E and E.
Okay. Okay. Which of the patients is thought to have a genotype that is protective against malaria?
Patient D.
Patient D, right?
Yeah.
Okay. How okay, that is fine. Please, are you following me?
Yes.
Doc.
So that is all I want you to know about HB electrophoresis, okay? You seem to be good, so that is fine. So let's go back to the question. So you see, in newborns, we don't use electrophoresis to aid electrophoresis to determine their genotype. We use, and it's available in Ghana, we use the isoelectric focusing. Use isoelectric focusing. And really, any newborn who has an HB SF, you see, he's not showing the other S because he has the fetal hemoglobin. The point is that any newborn, see, newborns before 6 months, they have fetal hemoglobin, so you'll not be seeing it so much. So any patient, any baby whose isoelectric focusing for determining genotype shows SF is likely to be a sickle cell anemic patient. He's likely to be SS. I'm repeating, any patient, any baby whose isoelectric focusing shows SF is likely to have sickle cell anemia in future. So in these people, because we want to prevent invasive pneumococcal infection, okay, invasive strep pneumo infection, we put them on penicillin. So the answer to that question was actually to start penicillin immediately. So the teaching point here is that any child whose isoelectric focusing shows SF pattern is likely to become obenia yakese na wadane so you have to start the penicillin. Are we good?
Yes, doc.
And so this brings us to the end of HB electrophoresis and the end of today's lecture. If there are no questions, have a good evening.
Good evening, doc.
Good evening.